Hello friends, in this video I'd like to solve the following problem from the Bulgarian Mathematical Olympiad for 4th round, 1994, problem number 2. We wish to find all functions f from the set of real numbers into itself, satisfying the following equation. X f of x minus y f of y equals x minus 1 y times f of x plus y for all real numbers x and y. So here are my hints for this problem. First, define a new function g of x which equals f of x minus f of 0 and try to rewrite our equation in terms of this new function g. Notice that g is known to have to attain the value of 0 at 0 and then set y to be minus x in our equation to show that our function g is odd, and then try changing y to minus y and compare g of x plus y with g of x minus y. And that should be sufficient. So give this problem a try and I will see you in just a minute. Alright, so as I suggested, let g of x equals f of x minus f of 0. Then we have the following. Instead of f of x, we can put g of x plus f of 0. Instead of f of y, we can put g of y plus f of 0. And on the right hand side, we have x minus y. In the parentheses, we have g of x plus y. G of x plus y plus f of 0. Right? And now let's simplify it. We have x g of x plus x f of 0 minus y g of y minus y f of 0 equals x minus y g of x plus y plus x f of 0 minus y f of 0. Now we see that some cancellations can be done, namely, here we have x f of 0, here we have x f of 0, here we have minus y f of 0, and here we have it as well. So it turns out that our function g satisfies the exactly the same equation. Exactly the same. So, and let's call this equation, you know what, let's call it asterisk. Let's see. Note that, well, g of 0, what is g of 0? G of 0 is f of 0 minus f of 0, so it's just 0. And now let's set some variables. First, let's try setting, let's first set y to be minus x in our condition asterisk. Then we have the following. We have x g of x minus x g of minus x equals 2x g of 0. G of 0 is 0, and on the left hand side we can factor out x, and we have g of x minus g, or rather plus g of minus x, and that equals 0. And notice that that means that for every number, real number x, g of x plus g of minus x is 0. Why is that? Well, because if x is 0, then we have 0 plus 0 equals 0, no problem there. And if x is not 0, we can divide by this variable, and that must be 0. All right, so in other words, i.e., g must be odd. Our function g must be odd. And now let's replace let's go back to our equation. Now what I wish to do is to replace y by minus 1. Replace y by minus y in our functional equation asterisk. Then we have the following. X g of x minus y, but minus y becomes plus y, g of minus y equals x plus y, I believe. Maybe let's put it in ellipsis to clear. Well, x minus minus y, so it's x plus y, g of x minus y. Alright, but now remember that our function is odd, so g of minus y can be written as minus y g of y. But also remember that this part right here, again by our condition asterisk, this part right here is exactly the same as x minus y g of x plus y. Yes? This equality is here is by condition asterisk once again. And now let's compare this equals that. So maybe let's write it for every real numbers x and y. X minus y g of x plus y equals x plus y g of x minus y. We have established that. Very well, very well. And in particular, what can we do? Well, in particular, we can now do the following. Let's make a change of variables. So now let a be equal x plus y, and let b be equal x minus y. Well, notice that then x can be written as a minus b over 2, and y can be written as a plus b over 2. And that means that for every two real numbers a and b, b times g of a equals a times g of b. Which is very nice because now we can set just b to be 1. So set b to be 1. Then we have the following. Well, we have just g of a equals g of 1 times a, which means that our function g is linear, i.e. g is linear. And let's go back to our original function f, because that means that f of x equals, well, g of x plus f of 0. So it's g of 1 times a times x plus f of 0, i.e. f is affine. Our function is affine. And now what we just need to do is to write our answer. Solutions. Well, f of x is any function of the form ax plus b, where a and b are any real numbers. But let's do verification. It's very important not to forget to do verification. And let me add a new page. Perfect. And now let's do verification. Let's do verification. On the left hand side, we have x f of x minus y f of y x ax plus b minus y ay plus b, which is ax squared minus ay squared plus bx minus by. And on the right hand side, we have x plus y, I believe. X minus y, sorry, x minus y, f of x plus y. Which is x minus y, ax plus ay plus b, which is ax squared minus ay squared plus bx minus by. It is exactly the same. Left hand side equals the right hand side. So it is verified, and every affine function is a solution of our equation. And that closes our problem. The solution set of our problem is the set of affine functions. And yes, thank you very much for watching. I will see you next time. Goodbye.